A few days ago, Sonia from UC Davis pointed out that when we use elastic demands and times, then the model actually reduces the investment in demand technologies when demands reduce. Now, this is not realistic because actually people may not buy fewer cars, but use the existing cars less, of course, within a certain range of demand reduction. So, this, of course, is a very valid observation. And so here is a quick and dirty way of making sure that the availability endogenously reduces when elastic demand reduction kicks in. Okay, so I've used the third step of the demo models for this demonstration. So there is one demand called TPS-ELC, and the process is demand technology DTPS-ELC, which consumes electricity and produces this demand. Now I have added an emission, a dummy emission called ED underscore this. So the basic idea is that this emission is not linked to the efficiency equation, but we will manually rewrite or overwrite in parallel the capacity equation, the cap to act equation, to make sure that the capacity is equal to the sum of these two flows. So let us see how I have done that. So first of all, how the elastic scenario is set up, just to frame things. So I created these elasticity parameters in a simple scenario, which is called scenario last pair, just the elast walk and step. Then to simulate, to activate the elastic demands, the electricity price had to be increased. So I have simply added 10 to the activity cost of all electricity plants. So in the scenario high ELC price, there is just a plus 10 on activity cost of all ELE. Okay, so that's how electricity price is increased and elastic parameters are defined. Now the main action happens in the, let's go back to this one. So these are the two UCs that are driving this design. So first of all, I say here that the commodity production of this demand plus the flow out of this dummy emission from this process is equal to the exogenously specified demand. Okay, so now this will actually reduce when the elastic demands are active, and then the model has to produce this to make sure that the overall demand is still met. So basically it will adjust the AF. Now important thing here is that right now we have only one process, but actually this equation could be written, it would be the same if we had more processes. This of course is an imperfection because then the model can produce more or less of this commodity from the different demand devices. But that I think you should use and see if there's a serious difference, then you put some flow marks and something to control the share. But this is definitely an imperfection in this design. And the other UC is doing the AF. So this is saying that this is the AF of the process. So this is saying that the sum of the flow of the demand and this dummy commodity is under the AF of the process. So that's about it. And with this, if you look at the results, then I ran 4 scenarios. The scenarios, yeah. So this is the original base run. Then this is the run with high electricity price. This is high electricity price with elastic demands, and this is the elastic demands with AF reduction simulation. So the key result is here. If you look at the X-rays of this process, so this is the demand production. So of course in the first 2 cases the demand is identical, then when ED kicks in, the demand production reduces, and it remains like that in the AF reduction simulation. Now look at the capacity variable. It's the same in the first two. It reduces in the third case when elastic demand. So this was the basic observation of Sonia, that the capacity reduces. But now in the fourth case, the capacity is back to where it was. And the electricity consumption and the demand production are still at the lower level. So in the first approximation, this seems to be a feasible solution. Now, of course, it's very kludgy. There's a lot of usage declaration to be done, but I'm sure someone else can find a much more elegant solution. For example, if you had access to the demand loss as a UC, then we will not have to use hard numbers for demand on the right hand side of the first UC. That could be inconvenient if you are running demand scenarios and so on. But anyway, that's it.